Hello, and welcome to today's lesson on congruence. I am glad that you are joining us. This is going to cover the topics in Standard 2.5 and under the Study Island topic called congruence. Congruence is when you have two polygons and they are the exact same size and shape. So they might be flipped or turned or reversed, but they're still the exact same polygon, exact same angles, exact same side lengths. And remember, when we are going through this video, you can always pause, stop, rewind. You should be taking notes as you go through. So if I go too fast, just go ahead and pause the video so you can get caught back up. And you can even pause at the beginning of a problem, work it out, see what you think the answer is, and then start watching the video again and see how you do. So I'm so glad that you're here, and let's go ahead and look at some notes. Right, like I said, congruent triangles they don't have to be in the same orientation or position. They only have to be identical in size and shape. So here we have two congruent triangles. And this side here is 9 centimeters and this side here is 9 centimeters. They're the same length, so those are called corresponding sides because they're the two sides that are the same size. The second side is 5 centimeters. Here's a second side that's 5 centimeters. Here's a third side that is 7 centimeters and a third side that's 7 centimeters. And then the angles also match. That's what makes it a congruent triangle. Once we know they're congruent, we can write what's called a congruent statement. So here is an example of a congruent statement. It says triangle ABC is congruent to triangle JKL. The equal sign with a little tilde on top, that's the symbol we use that means congruence. And so what a congruent statement means is it lines up all those corresponding parts for us. So if you notice, A and J are both the beginning letter. Angle A and angle J are the ones that are congruent. B and K are in the middle, so angle B and angle K are the ones that are congruent. C and L, they're the last in the congruent statement, so those ones are going to be congruent. And it works for the sides too. So side AB is AB is the first and second letters, JK is the first and second letters, so side AB is congruent with side JK. And then B and C are the second and third. K and L are the second and third. So B and C is congruent to side KL. And then last, the first and third letters are A, C, and J and L. So side CA is congruent to LJ, which that all makes sense. And knowing that little tidbit can help us to quickly answer some of these questions. All right, so it's often useful in geometry to prove that two triangles are congruent. Well, by definition, in order to do that, we have to prove all three angles are the congruent and all three sides are congruent. However, throughout the years, mathematicians have found 5 shortcuts or 5 theorems they've proven to show that you only need to know 3 pieces in order to prove they're congruent instead of all 6. So the first one is side, 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 which is SSS. That's their nickname for it. And that's just saying I have 3 side pairs that are congruent. Side angle side, or SAS, is the fact that you have 2 side pairs with an included angle. How the angle's in the middle of the name, that's important because that means that the angle is between the pair of sides. So these sides here are our congruent sides, and it makes up that angle that's congruent. So it could not have been this angle in brown or this angle in blue. That if it's side angle side, it has to be the included angle. It has to be this angle right here. Okay, the next one is angle side angle, which is you have 2 angle pairs and then the included side, which is the side between the pairs of angles. Okay, so once again, do you see how this side begins and ends at our angles? That's what makes it included. So it has to be an included side for ASA. That means if I know these two angles here, it can't be this angle here, and it can't, or side, and it can't be this side here. It has to be this side. And then the last one is side angle angle, which is, you know, two angle pairs, hence the two A's, but you know a side that isn't included. And that's when you can use SAA. Okay, just so you know, SSA, that's not a choice. Okay, that's not one of our shortcuts. Side angle is not a way of proving congruent triangles. And then the last one is hypotenuse leg. Hypotenuse leg, you can only use this one if you know it's a right triangle. Okay, so if you know it's a right triangle and you know the hypotenuses are congruent and you know one of the legs is congruent, then you know those are congruent triangles. So let's look at our first problem. Which of the following figures uses AAS corollary to show that the triangle EFG is congruent to triangle HIJ? So this is saying which one of these is a picture of angle, angle, side. So there's two A's and an S. So first thing that tells me is I have to have a picture that has two angle pairs and one side pair marked. So right away, I can get rid of X because that's three sides. And then I can also get rid of Y because it has two sides and an angle. Okay, Z, I have angle, angle, and a side. And then W, I have angle, angle, and a side. So in Z, this side is between the two angles, and in W, it's not between. So I need to look at it. The S isn't between the A's. So that means angle, angle, side. This is the one where the side is not between. It's not included. So my answer is going to be W. Okay, this question asks us to identify the theorem that tells us that triangle MNO is congruent to triangle PQR. So I look at what the tick marks to see what it is that I know. Okay, I have one side pair, I have another side pair, and I have an angle pair. So that means first off, I can look at it and say I only know a side, and an angle pairs. So that means my shortcut or my theorem name is going to have two S's and an A in it. Well, the only one that gives it to me that has that criteria is B. And if I look at it, B says side, angle, side. So the angle is between the two sides, which it is here. So I know B is the answer. This question also asks us to identify the theorem that proves that triangle MNO is congruent to triangle PQR. So I'm going to go up here and look at where I have tick marks. So I have one angle pair. I have one side pair. And then I have another angle pair. So that means I have my shortcut, my theorem, its name's going to have two A's and an S in it. Well, if I look at my answer choices, my only choice there is B. All right, B says angle, side, angle, which the S is between the two A's in the name. So that means my side has to be between the two angles, which it is. So my answer is definitely B. Okay, this question here says, according to the side theorem, or SSS, which of the following sets of relationships can be used to prove that the triangles pictured above are congruent? So that means I need to have, in order to use SSS, I need to have three side pairs congruent. So if I look at choice A, it has an angle pair, not three sides, so it can't be A. Choice B, I have a side pair. Oh, there's an angle pair, so it can't be B. I need 3 sides. Choice C, side pair. Oh, this is an angle pair. I know because of this angle symbol, so it can't be C. And D, I have 3 side pairs. So it's going to be D as my answer. And if I just want to double check it that it makes sense, side MO is congruent to PR. Okay, that makes sense. Side MN is congruent to PQ. Okay, that makes sense. And then side NO is congruent to QR. Okay, that makes sense. So my answer is definitely D. Okay, in this diagram, they tell you that triangle LMN is congruent to triangle UST. So which one of these must be true? Instead of eyeballing it with the diagram, I would use this congruent statement to find this answer. So MN is the second and third letter here. So that means MN is congruent to ST. Well, that's not what A says, so it can't be A. Okay, B talks about LN. LN, first and third letter. First and third letter here is UT. Okay, it's not, so that means LN is congruent to UT. That's not what this says, so it can't be B. Okay, but C does say that, so my answer is going to be C. Let's just make sure I don't make any mistakes. LM is my second and third is US. That means LM and US those sides are congruent. That's not what D says, so it can't be D. So it's definitely C for an answer. William drew the following triangles to show that triangle ABC is congruent to triangle LMN by the Sss theorem. Does William's drawings prove the congruent statement by the Sss theorem? Okay, so that just means I need to double check his tick marks with the congruent statement. So I have AB, first and second letters, and LM, first and second letters. So AB and LM need to match up. Well, AB has 2 tick marks and LM has 3. So those ones aren't marked correctly. The tick marks don't match. So that means he didn't mark those sides as a congruent pair. So my answer is going to be no, because the corresponding sides are not corresponding according to the congruent statement. So my answer is D. This question here says figure QRST and figure WXYZ are congruent parallelograms. So that means everything I know about parallelograms, congruent opposite sides, congruent opposite angles, all holds true in this problem. So it wants to know, what is the measure of angle W? So I'm going to put a question mark there because that's what I'm looking for. Okay, if these are congruent parallelograms, that means they're exact replicas of each other. So angle R is my second letter, X is my second letter, so I know R and X are going to match. So it means R is 107, that means X is going to be 107 degrees. Okay, and then I'm just going to fill in what I know about my other parallelograms. I know that consecutive angles add to 180 degrees. So I need 107 plus what gives me 180. So I'm going to take 180 minus 107, and that leaves me with 73 degrees. So that means W is 73 degrees, so my answer here is A. Right, in this problem here, they tell us that the length of side MN is 17 units, the length of side NP is 25 units, the length of MP is 13 units, and then they tell us this congruent statement, triangle MNP is congruent to triangle QSR. What is the length of side QS? Well, QS is the first and second letter, so that means it's congruent to MN. Well, MN is 17 units. So that means QS is also 17 units, and my answer is A. So all I had to do was be able to read the congruent statement there. Okay, in this problem here, I know that triangle XYZ is congruent to triangle VWU. So if the measure of angle YXZ equals 60 degrees, So I'm going to go ahead and mark that. And the measure of angle VUW is 42 minus 3x. So I'm going to go ahead and mark that. What is the value of x? Okay, so here I know all the angles of a triangle add to 180 degrees. So if I could figure out what V is, then I could set up an equation. Well, V is the same as x because they're both the first letters in the congruent statement, and x is 60. So I know V is also 60 since they're congruent triangles. So that means I can take these three angles, and I know they add to 180 degrees. So I can take my first angle as 60, add it to my second angle of 42 minus 3x, and add that to my third angle, the right angle, so that's 90 degrees, and that's going to be set equal to 180. And now I can solve that equation. So first thing I'm going to do is combine like terms. I only have one x term, so I'm just going to rewrite that minus 3x. And then I have three numbers, 60, 42, and 90. And that adds to 192. And that equals 180. So now it's a two-step equation. I'm going to subtract 192 from both sides. These cancel, and I'm left with just the minus 3x on this side, and that equals a negative 12 on this side. I divide both sides by negative 3. These negative 3's cancel, and then negative 12 divided by negative 3 is 4. So x equals 4. It just wanted to know what is the value of x. So I'm done, and my answer is A. Okay. The figure of QRST and figure WXYZ are congruent parallelograms. So I know the perimeter of QRST is 49.5. So what is the length of XY? Well, I know here everything matches, and it also tells me that QR is 16.5. So since I know that these are parallelograms, I know that the opposite side is also 16.5. And I know the entire perimeter is 49.5. So I already have 16.5 and a 16.5 accounted for in that. So I'm going to add those up. And that equals 33. So then I can go ahead and subtract that from the total perimeter to see what's left over. And when I do that subtraction, I'm left with 16.5. So that means I have 16.5 to split evenly amongst these two sides. So half of 16.5 is 8.25. So that means each of these sides is 8.25. I'm looking for the length of XY. So, and according here, X, Y are the two middle letters of my congruent statement. So that means it's the same length as RS. RS is 8.25. So my answer here is B, 8.25. Thank you for joining us today, and I hope you learned something new.